We are going to start with a new topic today, and that is graph theory. Okay. Before we using this particular chapter in computer science, we need to understand what is graph theory and where we are using it, and what are the real life applications that the graph theory has in the world of the human. Now let's come to the introduction. In introduction, we have got just the meaning of graph theory. Here we'll be explaining what exactly is a graph. See, graph contains two things. One is vertices and another is edges. If you are having doubt about these things, I'll take a simple example. This is a rectangle. This rectangle, these points where the sides are joining are called vertices, and these are called edges. The graph also looks something similar to this one, but it can be more complicated than this. This is a simple rectangle, and this is just a shape. Now what we are going to do is we are going to see a sample example, and before that we need to understand where these graphs are used, where the graphs are used. I think most of you have seen Google Maps. Google Maps are the representation of real world cities and the roads. Now let's imagine that there is a city and there is a road here. There is another city. There is a road. There is a city. There is a road. This is actually a graph. Graph is set of vertices and edges. Okay. And if you see another example, I can take example of internet. In internet we have got two things. One is node. Node means any computer or server, and this is the link, and this is again a computer or server. This way you can have any number of nodes. This is our graph, and this is a representation of a server, computer, or something. This is just a model to show you what a graph and where they are used in the real life scenarios. Okay. Now coming to the next topic, and that is definition of a graph. See, when you see the definition of graph G consists of a set V. This is set of vertices, and another set E. This is set of edges. And the representation of graph can be done as V is equal to V comma E. Just now we saw what is the meaning of V. V is the set of vertices, E is the set of edges. Okay. And if you see individually what is V does, V is a non-empty set of vertices, and then E is set of ordered pairs. Set of ordered pairs. You need to remember this particular word. Set of ordered pairs of vertices. Set of ordered pair of vertices. Now we have seen the definition. According to definition, we will be going to see a simple example. Okay. Okay, we'll be going to see a simple example. Let me choose a different color for drawing the diagram. Now let's consider I have got a edge, a vertex A, vertex B, vertex C, D, and E. Now imagine that there is a edge here, 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 and there is a edge here. Whenever you are representing this graph, you need to remember that you are going to write it as P of G is equal to. Can you tell me what are the elements, what are the vertices of this particular graph? A, B, C, D, and E. This is V of G, vertices of graph V of G, and E of G is written as, see, there is a edge from A to B, right? There is a edge from A to B, and therefore I'll be writing it as A comma B. Okay, and then there is a edge from A to B again, A to D. So A to D. Then if you go next, it is B to C, B to C. Again from B to D, B to D, and then D to E, D to E, and then A to C, E to. And now if you see that there are 5 vertices in the graph, and there are 1, 2, 3, 4, 5, 6 edges in the graph. So if you start counting this one, 1, 2, 3, 4, 5, 6, and there are 5 vertices. And this graph is represented as G is equal to V comma E, where V is equal to this and E is equal to this. That's all. This way we represent any given graph. Okay, in the next video we will be studying the undirected graphs and the directed graphs. Thank you.